Well, welcome back. This is our third video on acceleration. And so in this video, we're going to work through different examples and really get a good gut feeling of what is acceleration, how do we find it, what direction is it going, what does it mean? So from our last video, we saw that the definition of acceleration is a change in velocity over a change in time. And another way of writing that is final velocity minus initial velocity over a change in time. So change in velocity over change in time. So back to our fire truck. So our fire truck is going faster and faster and faster. And this time we added in our velocities here on the bottom. So for this, what I want you to do is for this first 4 seconds, find the velocity, find the acceleration of the fire truck in this first 4 seconds, and then find the acceleration of the truck in the second 4 seconds. So pause the video, and then when you come back, I will do it with you. Welcome back. Okay, so acceleration is a change in velocity over a change in time. It's final, so in this case it'd be 20 minus initial, which in this case is 0, over change in time, which is 4. So our acceleration is 4, and look at this, the units, it's centimeters per second on top per second on the bottom. Another way of writing that is 4 centimeters per second squared. On this side, acceleration is change in velocity over change in time. Our final here is 40. Our initial is right here, which is 20. And our change in time is still 4. So it's still 20 over 4, which is, oh my goodness, it's not 4. It's 5. Good gravy. Okay, 20 over 4. Sorry, it's 5 centimeters per second squared. So, even though the fire truck is speeding up, speeding up, speeding up, speeding up, speeding up, and getting faster, 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 the way in which it's getting faster is the same. It's getting faster at the same rate, if you will. So the acceleration is constant, but the speed is not. The speed keeps getting faster. So we're going to work with this. Change of velocity was 20 for each. So let's work out a problem. A car is moving, well, take a moment, read this, and then pause it, come back, and I will work it out with you. Welcome back. A car is moving at 50 miles per hour east. 10 seconds later, it's moving at 70 miles per hour, still going east, so it's sped up in the same direction. Find the car's acceleration. Magnitude means how large, and direction. So acceleration is final velocity, which is 70 miles per hour, minus the initial, which is 50, over 10 seconds. So 20 miles per hour is our change in velocity over 10 seconds. So this is 2 miles per hour per second. So which means each second we're speeding up 2 miles per hour. This is just our magnitude, and our direction is east. Okay. Let's try one more problem. Have a go at this problem, pause the video, and then we'll work it out together. Ooh, this period is done. So, a bear is running at 4 meters per second north. The acceleration of the bear is 3 meters per second squared north. What is the bear's velocity 2 seconds later? So, acceleration is change in velocity over change in time. So, this is the initial velocity right here. And then we're given the acceleration of the bear. So, the acceleration is 3 meters per second. Final velocity minus initial velocity, which is 4, over 2. So then we multiply both sides by 2, so we get 6 is equal to VF minus 4. So the final velocity is 10 meters per second north. But you could reason this out. You could say the acceleration, since it's in the same direction as the velocity, just means that every second, so let me change this, 3 meters per second. So every second, the bear is speeding up by 3 meters per second. So if we start at 4, 1 second later, we're going to be at 7. 2 seconds later, we'll be at 10. So you could, you can reason out this answer without doing all the math. It's good to kind of get in the habit of doing both so you could check yourself, see if your answers are reasonable. Okay, you could also do it with a picture. So, in this case, try to find the acceleration. You will need a change in time. Okay, so acceleration is change in velocity over change in time. So, hi, I'm recording this for my class. Say hi. Hi. So, we have 6 meters per second minus the initial, which is 9, over 2 seconds. So it's negative 3/2 meters per second squared. The negative tells us that the acceleration is down or backwards. So the acceleration would be going down the incline, as you might suspect. We'll talk about this in just a second. Okay, so a key point, acceleration is the measure of the change of velocity that occurs in a unit time interval. So that is the key point of this thing. So you could think of acceleration as kind of a push. It's appropriate to think of it that way. So this one picture of this jet plane getting faster and faster and faster, the acceleration is going in the same direction as velocity. So think of it as the acceleration pushing the velocity to get faster. In this case, the drag racer is slowing down and the acceleration is opposite the velocity. So you think of the acceleration as pushing the velocity back or making it shorter, smushing it. So when acceleration is in the same direction as velocity, it speeds up. And when acceleration is in the opposite direction of velocity, things are slowing down. So acceleration means speed up and slow down. We will not use the term deceleration in this class, because deceleration, sometimes people say it's slowing down, but sometimes mean negative, and it gets confusing because they don't always mean the same thing. So acceleration is both speed up and slow down, and we'll use the context of the problem to find out what's going on. Well, the bell rang. It's getting busy in here, so I will stop this and we'll do some more examples in the next video.